Okay. Weightage. First, let's talk about the weightage. Let's directly go into the subject then after. Weightage, it's from 10 to 12 marks. Whatever the IIT gives you the paper, the 100% the weightage ranges minimum 10 marks. That is for sure. And why it is important? Once, can you please confirm me? My voice is audible, right?
Yes, sir.
My screen is visible?
Yes, sir.
Great. Now, the weightage ranges from 10 to 12 marks. And why environmental should be practiced? I'm telling you. This is the questions in environmental are easy related to other subjects. You will feel at the end of the session, that is at the end of tomorrow's session, you yourself will feel the same. Okay.
Yes,
First one is water supply engineering. The second part is wastewater engineering. The third part is air pollution and control. Fourth part is solid waste management. In engineering services examination, we also have noise pollution and control. But in gate exam, we don't have noise pollution and control. Okay. Today, and from this, I can say we will be getting 4 to 6 marks from water supply engineering, 4 to 5 marks, minimum 4 marks, I can say, 4 to 5 marks from wastewater engineering, 2 to 4 marks from air pollution and control, 2 marks from solid waste management. Understood the weightage?
Yes, sir.
Now, in water supply engineering, what are the topics we need to focus? Because we are not going to teach everything now.
Yes,
so,
sir.
main importantly, we can expect the questions on sedimentation. And next, we can expect the questions on filtration. We can expect the questions on disinfection. Understood, my dear?
Yes, sir.
That means I'm not telling other topics are not important, but whether you are getting questions from them or not, it doesn't matter. But 100% I can say you can get 2 mark questions from these topics.
Okay, sir.
That is from today's class itself. Minimum you can score 3 to 4 marks from today's class itself.
Yes, sir.
Okay.
Okay, sir.
Let's go into sedimentation first. Let's dive into sedimentation first. So, what is sedimentation? Tell me.
So, settling when a particle is
Yeah, here we will look into sedimentation. Sedimentation is generally carried out in sedimentation tanks.
yes,
They can be of rectangular shape or circular shape. You need to remember it. Now, in sedimentation, what we need to focus is, I'm assuming this is your sedimentation tank.
yes, sir.
This is how your sedimentation tank looks like. Is it?
Yes.
Length, width, let's take capital L, capital B, capital H. Length, width, height. Okay. Now, if we take the sedimentation tank, this is the water. A particle whose specific gravity is greater than that of water has a tendency to settle down. Yes or no?
Yes, sir.
And bottom, the force we have is gravitational force. Upwards, the force what we have is buoyancy force. And always, for now, when is the particle going to settle? Tell me.
When gravity force is greater than buoyancy force.
Now, I can take a resultant force. Since both are in the same line of action, I can take a resultant force. If the particle need to settle down, in which direction the resultant force acts?
Sir, in
Settling means it should act in downward direction.
yes, sir. Yes, sir.
Now, apart from this, this is your resultant force. Apart from this, there is one more force called as drag force.
Yes.
Why? Because the water is never stationary. Water always remains in motion. That is, water keeps on going through the sedimentation tank. We are not allowing the water to be stationary. Earlier we used to do that, but now we are not doing it.
Yes, sir.
Now, for the particle to settle down like this in a parabolic fashion, which should be greater? Drag force should be greater or resultant force?
Resultant force.
Resultant force should be greater than drag force. Yes or no?
Yes, sir.
Now, let's leave about the derivation, all these things we don't require. Very important thing. What is the equation for settling velocity of the particle? Particle settles down with a velocity known as settling velocity.
Yes, sir.
The equation is Vs settling velocity equal to z by 18 s minus 1 d square upon nu. What is nu?
Sir, kinematic viscosity.
Very good. Coefficient of
Extent of
kinematic
kinematic viscosity.
viscosity. What is d?
D is dia of particle.
Minimum diameter of the particle or simply diameter of the particle. In
Yes,
some questions, they will confuse you with what is the minimum diameter. Don't get worried. Whatever the d you are getting here, that is your minimum diameter.
yes, sir.
This is the important tip I wanted to tell you, because if a particle of diameter 0.3 micron is settling down, a particle of diameter 0.4 will 100% settle down.
Yes, sir.
And particles are assumed to be spherical in shape.
Yes, sir.
And particles are assumed to be discrete. Discrete means whose size, shape, volume never be changed. And what is S?
Specific gravity.
Specific gravity, very good. You know G is 9.81
Yes, sir.
kilonewton per meter, Newton per meter per second square.
Yes, sir.
And next units of this is opposite to meter per second square. That is meter square per second.
Yes.
This is meter per second square. Even if you are given mu also, convert it to nu.
Yes, sir. By dividing it with density.
Rho.
Yes, sir.
Now, directly, this is the equation as I told you.
Yes, sir.
Next, apart from this, the first formula, what we discussed, holds good when this formula holds good if diameter of the particle is less than 0.1 mm. Directly assume, whenever they gives you, directly assume the diameter of the particle to be less than 0.1 mm, proceed with this equation. So I am writing the equation for you again here. Vs equal to z by 18. Can you see me? See what
Yes,
I'm
sir.
writing?
Yes, sir.
This equation we call it as Stokes law or Stokes equation.
Yes, sir.
Or suppose if diameter of particle less than 0.1 mm, in the question it is mentioned, if it is mentioned in the question, what happened? Just a minute. In the question, if it is mentioned, take temperature into consideration. Okay. If it is given, take T into consideration. Can you hear me?
Yes, sir.
Very good. Very good. Sorry for the delay. Yeah. Now we will be having the equation Vs is equal to 418 s minus 1 d square 3t plus 70 upon 100. Okay.
Yes, sir.
418 s minus 1 3t plus 70 upon 100.
Wait.
That is the equation for settling velocity. Now, how to remember this? If you remember this equation, see,
Yes, sir.
instead of z, you take this 18 to the top. Instead of z, you write 4.
Yes, sir.
It happens to be 418. Yes or no?
Yes, sir.
S minus 1 d square is common.
Yes, sir.
Since they told to take temperature into consideration, we take 3t plus 70. Assume t means 10.
Yes, sir.
What is 310? 3 into 10, 30 plus 70 is?
100.
We have at the bottom.
Yes, sir.
Like that you can remember.
Yes, sir.
Now, for suppose, if the diameter of the particle ranges from 0.1 mm to 1 mm, we have an equation Vs is equal to same as equation 2, but remove d square. Just keep it d. 418 s minus 1 d 3t plus 70 upon 100. Understood?
Yes, sir.
Equation 2 and equation 3, we call them as Hazen's equation.
Yes, sir.
D greater than 1 mm, Vs is equal to 1.8 into root over z d s minus 1. This is also known as Stokes equation. Okay,
Okay, sir.
clear?
Clear, sir.
Shall we move forward? We will directly see the design aspects so that we will solve some questions.
Yes, sir.
Now, yeah, listen. You know, volume of sedimentation tank is L into B into H. So, no,
Yes, sir.
surface area is equal to L into B.
Yes, sir.
Cross section area is equal to B into H.
Yes, sir.
I am drawing the sedimentation tank again for you. Okay.
Yes,
L,
sir.
B, H. Now, first we have SLR, surface loading rate. What is SLR? Surface loading
Right.
rate. Or we also call it as overflow velocity. O means overflow, V means velocity.
Yes, sir.
That is generally in what direction we load the water. Yes,
Downward.
along the height only, downward along the height only.
Yes, sir.
When you are loading along the height, what are the two perpendicular parameters we have?
Sir, wait.
L
Wait.
and B.
Yes, sir.
So this L and B is your surface area.
Yes, sir.
Take surface area into consideration. You know Q is equal to AV.
Yes, sir.
From this only we derive everything. V equal to Q by A. Here Q by which area we need to take?
Surface area.
Surface area. See, after loading, water goes in which direction? Along which direction?
Length.
Along the length. So what are the perpendicular area?
Sir,
Along the length, close length. What are other parameters you have?
what, sir?
Along the length means don't take length into consideration. What are other parameters you have?
E and H.
B and H, that's it. B into H, we call it as cross section area.
Yes, sir. Cross section area.
Okay. Now, VH, we call it as flow through velocity. What is VH?
Flow through velocity.
Flow through velocity.
Yes, sir.
VH is given by Q by BH. What is BH? Cross section area.
Cross section area.
Next, we know volume. If you know volume, if you know Q, what is dt? Dt means detention time.
Yes, sir.
That means how much time do a particle or else a stream of water stays inside the tank.
Yes, sir.
How much time does a stream of particles stays inside the tank? We call it as detention time.
Yes, sir. Yes, sir.
So that we call it as detention time. So that is detention time. So you know this, right? V equal to Q into dt.
Yes, sir.
Yes or no?
Yes, sir.
Okay, good. And for settling of particles, always detention time and settling time, which should be greater? Tell me. For particles to get
Set.
settled down, which should be greater? That
Yes, sir.
means, for suppose, I'll tell you an example. If a particle take 3 hours to settle and detention time is 2 hours, that means particle is staying in the tank for 2 hours, but settling time is 3 hours. Will it settle down or will it go out?
No, sir. It will
It
go
will
out.
go out, right?
Yes, sir.
So for particles to settle, detention time should be greater than
Settling time.
settling time. Detention time means, you know, velocity equal to distance by time, time equal to distance by velocity. Yes or no?
Yes, sir.
In detention time, that is, in detention time, particle is traveling along which direction?
Along the length, sir.
Length
Yes, sir.
L. So the distance is L. With what velocity is it traveling along the length? With what velocity is it traveling?
Flow through velocity.
VH. Very good. That should be greater than or equal to settling means settling occurs in which direction?
Down and along the height.
Height.
Depth.
So that is the distance is h. With what velocity will it settle?
Settling velocity.
Very good. So for particle to settle down, the equation what we require is what? L by VH equal to H by Vs.
Yes, sir.
Now let's do the questions now. If any more concepts are required, I'll discuss there itself.
Yes, sir.
Yeah. See this. Can you do this?
Sir, let me try, sir.
A suspension of sand-like particles in water with particles of diameter is given to you.
Yes,
What
sir.
is diameter? How much?
1.10 mm.
0.1 mm.
Yes, sir.
Next is flowing into a settling tank. What we have is D less than or equal to 0.1 mm. We can use which equation?
Sir, Stokes.
Stokes equation. Equation 1.
Yes, sir.
Settling tank. This is what is this one? Meter cube per second means it is
Discharge.
discharge. Specific gravity is given, specific gravity, acceleration due to gravity is given, kinematic coefficient of water is given. Convert this to SI units.
Yes, sir.
Minimum surface area required for settling tank to remove the particles of size 0.06 mm with 100% efficiency. I have a doubt here. He is telling particles of size 0.1 mm is present. That means particles of size 0.1 mm is present and particles of greater diameter may also be present. They will settle down 100%.
Yes, sir.
Okay. But he is asking about which sized particles.
0.06 mm.
So why is this given? Just to create a
It's for
confusion.
confusing. Confusion.
Understood?
Yes, sir.
What is required? We required to settle down which sized particle?
0.06 mm.
If 0.06 mm particle is settling down means
Yes, sir.
this is greater than that and that will also settle down 100%.
Yes, sir.
Now tell me. Now tell me how do we approach for this? Think.
Sir, we can't apply Stokes equation.
Mhm.
So,
First tell me what are we asked?
sir, minimum surface area we need to calculate volume. Then we will.
V naught, we already have the equation. V naught is equal to Q by surface area.
Yes, sir.
Yes or no?
Yes, sir.
Now what we assume is we already also we have the equation. Efficiency is Vs by V naught into 100. What is the equation for efficiency?
Vs by V naught into 100.
Eta equal to Vs by V naught into 100. But what is the efficiency we have?
100%.
100%. So 100 gets cancelled.
Yes,
What
sir.
is Vs?
Vs equals to V naught, sir.
So in this equation, this is Q is already known.
Yes, sir.
If you know V naught, then you will be getting surface area.
Yes, sir.
How do we get V naught? That is indirectly by calculating Vs.
Yes, sir.
What is Vs? Z by 18,
Yes, sir.
S minus 1, D square upon nu.
Yes, sir.
C is 9.81 upon 18. What is specific gravity?
Specific gravity is 2.65.
2.65 minus 1. Sometimes instead of specific gravity, they will give you density of particle
Yes, sir.
2500, 2600 like that.
Yes, sir.
Directly divide it with 1000 and take the value.
Yes, sir.
Okay, since 1000 is the density of water. And next, what is the size of particle?
0.06 mm.
But we require it in
10 to the power
minus 3
minus 3.
whole square. Since we require it in meters,
Yes.
by coefficient of kinematic viscosity, how much it is?
1.01.
0105 into 10 power minus 2 centimeter square per second. But I want it in meter square per second.
10 to the power minus 2 into 10 to the whole power.
Minus 4
Yes, sir.
because centimeter is 10 power minus 2 meter whole square.
Yes, sir.
Now tell me the answer.
3.20 into 10 power minus 3.
It's 3.20 into
10 power minus 3.
units.
So units are
Listen, listen. The units of G is meter per second square
yes, sir.
into specific gravity having no units.
Units.
We are substituting diameter in meter square it becomes.
Yes, sir.
And this unit is meter square per second.
Yes, sir.
So meter square get cancelled. Second get cancelled here. So the unit what we are left with is
Meter per second.
SI units for velocity.
Yes, sir.
Now we know Vs that is equal to V naught.
Yes, sir.
Now V naught equal to Q by surface area. 3.2 into 10 power minus 3 is equal to surface Q is how much?
Q is
0.1 meter cube per second. This is meter per second
Yes.
upon surface area. What is surface area then? Meter cube per second upon meter per second. Second get cancelled. This gives you in meter square.
31.25.
How much it is?
31.25
Very good.
meter per second. Sorry,
That
meter square.
31.25 meter square.
Yes.
Understood?
Yes, sir.
Any confusion in this question?
No, sir.
Directly what we do is only confusion is which diameter we need to take.
Yes,
Which
sir.
particles we need to remove, the same diameter we need to consider.
Yes, sir.
And we need to use efficiency equation, or else if efficiency is not given, what we assume directly Vs is equal to V0.
Okay, sir. If it is not mentioned that efficiency is 100%, we can at that time also we can take Vs equals to V naught.
If he does not give, or if he mention 100%, always take Vs equal to V0.
Okay, sir.
If efficiency is given other value, any value other than 100, then
Yes,
we
sir.
use this equation.
Okay, sir.
Understood?
Okay, sir.
That is one shortcut.
Yes.
Always follow this equation blindly. Vs equal to z by 18 s minus 1 d square upon mu. Even
Yes.
in sleep also we need to remember this equation.
Yes, sir.
Shall we move forward?
Yes, sir. Sir, like yesterday, will you share the notes after class?
No need to ask me. 100% I'll share it every day, every night
Okay,
after
sir.
the class.
Okay, thank you, sir.
Okay?
Yes.
You feel it as my responsibility. I'll do it 100%. See, whatever the things you feel I can help you, I'll do it for sure.
Okay, sir.
Okay? Let's see the next question. Consider a primary sedimentation tank. That is nothing but sedimentation tank
Yes, sir.
in a water treatment plant with surface overflow rate. What does it mean?
Surface loading rate.
That is nothing but surface loading rate. Same.
We know.
Surface overflow rate has other name, surface loading rate.
Yes, sir.
SLR or SOR or overflow velocity V0. All are same.
Yes, sir.
Or else here if you see, what is meter cube per meter square?
Meter. Meter per day.
Generally what we think is, if we gave like this meter cube per meter square per day, you don't take this, you don't bring this d to the numerator. Why it is? That means what does it mean? 40 meter cube of water. Are you getting my point?
Yes, sir.
40 meter cube of water is loaded per 1 meter square of area per 1 day.
Yes, sir.
That means how we need to take it is 40 meter cube of water is loaded per 1 meter square of area per 1 day. Like this we need to take.
Okay, sir.
Now, this is nothing but meter cube per meter square means it's meter. Yes or no?
Yes, sir.
Meter per day. Can you convert day to second?
Yes, sir.
That means meter per second means what it is? Velocity.
Velocity.
The diameter of the spherical particle, already I told you. Particles are assumed what shape?
Spherical.
Spherical. Which percent he given you?
90%.
Assume the settling velocity is described by which law?
Stokes law.
Stokes law means directly what equation we have? First tell me the equation.
Vs equals to G by
18
18 S
s
minus.
minus 1 d square upon nu. Now, what is efficiency given to us?
Sir, efficiency is 90%.
Eta equal to Vs by V0 into 100. That is equal to 90.
90%.
Now, how much is Vs then?
Vs.
Vs is equal to 90 by 100 into V0. Yes or no?
Yes, sir.
I want V0 in terms of Vs because we will be getting Vs from here.
Yes, sir.
Vs into 100 upon 90. Am I right?
Yes, sir.
Okay. Now let's calculate Vs. G is how much?
9.81
By 18. How much is specific gravity?
to sir 2.6
5. Is it?
2.5. Yes, sir.
We have the density 2650 divided with 1000. You will be getting 2.65.
Yes, sir.
Minus 1. How much is diameter?
Diameter is
That is what we asked.
yes, sir.
D square upon nu. Okay. We
Yes, sir.
know nu. How much is nu?
1.10 into 10
Into
power.
10 power minus 6. Always do remember one point. Nu always will be in the range of 0.8 into 10 power minus 6 to 1.2 into 10 power minus 6 meter per second.
Okay, sir.
Understanding?
Yes, sir.
Because the flow should be laminar.
Yes, sir.
While discussing, I will cover some more points also.
Yes, sir.
Okay. And like this. Now, we don't know Vs, we don't know diameter. We want diameter. In order to find out diameter, can we get Vs now?
Yes, from Stokes.
From this equation, we can get Vs.
Yes,
Am I
sir.
right?
Yes, sir.
Now, tell me, V naught is given to us. How much?
40 meter per second.
Listen, V naught 40 is equal to Vs into 100 by 90. Now, what is Vs? Vs equal to 40 into 90 by 100. How much is it?
36.
36 units, please. Unit of this.
Sir, meter per day.
But I want an SI unit. SI unit means 36
Per
upon
second. 36 upon 24 into 60 into
1 day, 1 hour. 1 day is 24 hours. 1 hour is
60 minutes.
60 minutes. 1 minute is 60 seconds.
Seconds.
How much is it, Norma?
Sir, 4.16 into 10 power minus 4.
4.16 into 10 power minus
4.
4 units
Sir, meter per second.
meter per second. Substitute it here. Vs is equal to 4.16 into 10 power minus 4 meter per second is equal to 9.81 by 18, 2.65 minus 1, d square upon 1.1 into 10 power minus 6 meter square per second. From this get d, you will be getting d in meter. Tell me the value of d first.
2.25 into 10 power minus 8.
2.25 into
10 power minus 8.
that. Can we check once again? Let me check for you. That's initially we have 36 meter per day. Divide by 24. Divide by 16 to 60. 4.16 into 10 power minus 4 we got. That's right. Perfect. Now 4.16 into 10 power minus 4 uh, into 18 divided by 9.81. Next, divide by 1.65 into 1.1 into 10 power minus 6. We got some 5.00088 into 10 power minus 10. When we are going for square root, I'm getting 2.225 into 10 power minus 5. Can you check once again?
Yes, sir. I have substituted the value 4.16 into 10 power minus 2 instead of minus 4.
Okay.
That's why I think I got wrong.
2.25 into 10 power minus 5 meter. Now, I want the conversion meter. 1 meter is 1000 mm.
Yes, sir.
1 mm is 10 cube, 1000 micrometer.
10 power minus 2.
1 mm is 10 cube micrometer.
Yes, sir.
Okay.
Yes, sir.
Therefore, I can say 1 meter is 10 power 6. 10 cube into 10 cube. 10 power 6 micrometer.
Yes, sir.
Now, if I'm multiplying, but we are asked in micrometer. Therefore, multiply into 10 power minus 6.
Yes, sir.
22.5 micrometer.
Yes, sir.
Any doubt in this question? Once
No,
have a
sir.
glance at it. Any doubt do you
No,
have
sir.
in this question?
Yes, sir.
Okay. Shall we move on to the next question?
Yes, sir.
Let's have an idea and leave this. Spherical grid particle have a radius. Radius is 0.01 mm. How much is diameter?
2 times 0.02.
Very good. Specific gravity is 3. Need to be separated in settling chamber. That means sedimentation tank only. G is given. Density of liquid in the chamber. Liquid means what? Water.
Water. 1000 kg.
Kinematic viscosity is given. Settling velocity. Can you do this?
Yes, sir.
Tell me. Vs equal to V by 18
S minus 1 D.
minus 1
Yeah.
d square upon nu.
Mm.
Is it?
Yes, sir.
You know Z. You know S. Specific gravity you know directly 3.
Yes, sir.
You know diameter.
Mu as well.
You know kinematic coefficient of viscosity.
Yes, sir.
Direct substitution, right?
Yes, sir.
Can we move forward?
Yes, sir.
Let's see this. A municipal corporation is required to treat 1000 meter cube per day of water. That is, what is 1000 meter cube per day? Is it discharge?
Yes, sir.
1000 meter cube per day. It is found that overflow rate of 20 meter per day will provide a satisfactory removal of discrete suspended particles at a depth of 3 meter. Okay.
Yes, sir.
That is what he given you is Q is given. Overflow rate means what it is?
V naught.
V naught. Very good. 20 meter per day. Good. Mhm. Will provide a satisfactory removal he gave. Depth 3 meter he gave. Depth means height.
H.
Am I right? H.
Yes, sir.
Diameter of a circular settling tank. Circular settling tank. Remember this.
Yes, sir.
Designed for removal of this particle would be. He's asking you the diameter.
Diameter.
So let's do one thing. You know, V naught is equal to Q by surface area.
Yes, sir.
Yes or no?
Yes, sir.
From this get surface area. Q by V naught.
Yes, sir.
How much it is?
50.
50
50.
units
50 meters square. Meter square.
per good. Now, if it is a rectangle, surface area is equal to L into B.
Yes, sir.
But it's not a rectangle.
Circle.
It's a
Pi by 4d square.
okay. Here actually the confusion starts for us. We should not take pi by 4 d square. Why I'll tell you. Just a minute, please. Just a minute. I want to discuss a point here.
Yes, sir.
Yeah. Circular sedimentation tanks looks like this. If it is completely circular throughout the bottom, we take pi by 4 d square. But what happens is, this is how you load water. Yes or no?
Yes, sir.
This is how it goes outside, flow of water.
Yes, sir.
This portion AB, I call it as settling zone. What do we call it, ma?
Settling zone.
Sorry, it's not settling zone, zone of flow.
Zone of flow.
And or settling zone. You can say settling zone, no problem. And all the settled particles comes and get stored in this portion BC.
Yes, sir.
This we call it as sludge zone. What do we call it?
Sludge zone.
Sludge zone. Sludge means particles which are settled. We call it as sludge.
Yes, sir.
Okay. Now we need to consider this surface area means we should not only consider the circular portion. We need to consider this surface area also.
Yes, sir.
Now, what is the equation is surface area for circular settling tank is d square into 0.011 d plus 0.785 h upon that's it. That's it. Sorry. Surface area is how much?
D square into 0.011 D plus 0.785 H.
What is 0.785 pi by 4?
Okay, sir. Pi by 4 H.
Now, let's do one thing. Substitute, equate both the things. or else, yeah. Can you calculate it? Else do one thing.
H is 3 meter.
H is 3 meter. If you have any problem, do one thing. I'll tell you a tip here. If you don't know this formula, let's assume you don't know this formula, you forgot this formula. This is the actual formula what we need to use. For suppose, if we forgot this formula, I'll tell you a tip here. As we know the formula of settling zone as pi by 4 d square, yes or no?
Yes, sir.
Okay, pi by 4 d square, we know the formula. Directly do equate it to 50. D square is equal to 50 into 4 by pi. How much is d then?
63.9.
There is a small confusion, my dear. This is the formula for volume, not for the area.
Okay.
This is the formula for volume. D square into 0.011 d plus 0.785 h is the volume formula for what?
Volume.
Volume of circular sedimentation tank.
Okay, sir.
Understood?
Yes, sir.
So directly we will be getting from this d square is equal to 50 into 4 by pi.
Yes, sir.
Instead of pi by 4 d square h, this is the formula for volume. Do remember?
Okay, sir.
Tell me the value of d from this.
Sir, volume can be calculated by multiplying surface area with height, and which can be equated to this equation.
That is what I'm telling you. Don't do that. Volume for a circular sedimentation tank, we have a formula that is d square into 0.011 d plus 0.785 h.
Yes,
If
sir.
it is rectangle tank, what you told is 100% right.
Yes, sir.
Because if it is rectangle tank, it will be rectangular throughout.
Yes, sir.
Up to some portion it's circular and it's having some cone portion at the bottom.
Yes, sir.
What is the diameter we have here?
Sir, 63.694.
Is it d square equal to 200 by pi? D is how
Okay,
much?
sir. Okay, sir. D. This is D square, so 63 point.
Yeah. Try to be very keen in each and every step.
Sir, 9.007.
No. D square is something 63, you told me. When D square is 63, you will be getting D as 8 meter only. Root of 64 is 8.
Yes, sir. Just one.
Yes or no?
Yes, sir.
Approximately 8 meter.
Yes, sir.
Shall we move on?
Yes, sir.
Let's do this. We'll move to the next topic after this. Or else we will see another question. I'll explain you briefly this one. Sedimentation basin in water treatment plant is designed for flow rate. How much?
0.2 meters cube per
What it is then? Flow rate means discharge.
Yes, sir.
0.2 meter cube per second. Basin rectangular, that is sedimentation tank is rectangular. Length is given L, B, H. All the three things are given. Can you work out volume?
Yes, sir.
L into B into H.
32 into 8 into 4.
Settling velocity is governed by Stokes law. Okay. Density of particle 2.5 gram per cc. That is specific gravity is how much? 2.5.
Yes, sir.
Dynamic viscosity is given. I want mu by rho.
Yes, sir.
Clear?
Yes.
Particles of diameter how much?
25 micrometer.
Shall we do this?
Yes, sir.
Okay. Do one thing then. First, tell me the volume, how much it is.
32 into 8 into 4. Sir, 1024.
1024
Yes, sir.
meter cube, right?
Yes, sir. Yes,
We have the equation eta equal to Vs by V naught into 100. Now, um, first we want Vs, then we can calculate V naught. First, let's calculate V naught then. What is V naught? How do we get V naught?
sir. Q by surface.
L into B.
Sir.
So Q is 0.2 meter cube per second. L into B is 32 into 8 meter square. What is the answer?
7.8125 into 10 power minus 4.
7.8125 into
10 power minus 4.
10 power minus
4.
4.
Yes, sir.
Okay, meter per second.
Yes, sir.
Now, let us calculate Vs. What is Vs? Tell me.
Just a minute.
3 by 18, 9.81 by 18. Specific gravity is how much?
Specific gravity 2.5.
Minus 1. Z by 18, S minus 1. What is diameter?
Diameter is 32
25 micrometer.
25 micrometer.
Yes or no?
Yes, sir.
So 25 micrometer is how much meter?
10 power minus 6.
Very good. D square upon nu. Nu is mu by rho. How much is nu then tell me?
Is mu given as 0.01 divided by 0.01 divided by density is 9.
Can I tell you a shortcut here?
Yes, sir.
What is the quotient you have?
Sir, 0.01.
0.01, right?
Yes, sir.
Do one thing. It's directly 1 into 10 power minus 6 meter square per second. Because already I told you in laminar flow, what is the range of nu? 0.8 into 10 power minus 6 to 1.2 into 10 power minus 6.
Yes,
For
sir.
suppose, if you have it as 0.012, how much it is then? That is 1.2 into 10 power minus 6.
Yes, sir.
If you have 0.009, then we take it as zero point 0.9 into 10 power minus 6. Understood?
Yes, sir.
No need of wasting time.
Yes, sir.
Tell me the Vs value.
5.109 into 10 power minus 4.
5.109 into
10 power minus 4.
10 power minus 4 meter per second.
Yes,
Now
sir.
what is eta then? Vs by V naught.
Yes, sir.
5.109 into 10 power minus 4 upon 7.8125 into 10 power minus 4. What is the answer then? Into 100.
Yes, sir. Sir, 65 into 65.39.
So that is equal to how much percent then?
So 65.39%.
We have the option 65.
Yes, sir.
That's it.
Okay, sir.
Clear?
Yes, sir.
We'll do this question directly. A rapid sand filter comprising a number of filter beds is required to produce 99 mld of potable water. This comes under filtration. First is what is mld? Tell me.
Million liter per day.
So that is first let's convert mld to meter cube per second. 99 into 10 power 6 liter per day. Yes or no?
Yes, sir.
So that's 99 into 10 power 6 into 10 power minus 3 meter cube.
Yes, sir.
Yes or no? 1
Yes.
meter cube is 1000 liter. 1
Yes.
liter is 10 power minus 3 meter cube.
Yes, sir.
One day, shall we convert day to hours or seconds? It depends on the units given to make it simplified.
Yes, sir.
Rate of filtration, that is velocity of filtration, is given in which unit?
Meter per hour.
So let's convert this to meter cube per hour only then.
Yes, sir.
Understanding?
Yes, sir. 20.
So we are getting how much is the value of Q then tell me in meter cube per hour?
Four thousand one twenty-five. 125.
How much it is?
4125.
2125.
4,000.
4125. Am I right?
Yes, sir.
4125 meter cube per hour.
Yes, sir.
Okay. Then water loss during backwash is 5%. That is, in backwashing, we are losing. See, what is backwashing? In rapid sand filter, we clean the filter using purified water only. Okay.
Yes, sir.
So for that we use backwashing.
Yes, sir.
Now that is uh, filtered discharge is how much? Q filtered net or else net discharge is how much? 5% is used for backwash. That means how much is remaining?
95.
95%. And what is, wait. A rapid sand filter comprising a number of filter beds is required to produce 99. Are you understanding, my dear? There is some twist here. It need to produce 99. In order to produce 99,
Yes, sir.
how
Yes.
much it should treat? Are you understanding my point here? Can I tell you in a simplified way?
Yes, sir.
You want some 1000 liter filtered water.
Yes, sir.
Okay. After filtration and all the requirements, you require 1000 liter.
Yes, sir.
If you are treating 1000 liter, if you are treating 1000 liter, 5% is used for backwash.
Yes, sir.
That means how much are you getting in turn then?
So 95%.
95%. That is 950 only.
Yes, sir. Yes, sir.
But how much you want? 1000. That
1000.
means how much you need to treat?
Sir, more than 1000.
More than 1000. Very good. So that is 4.25 divided by, sorry, into 1.05.
Yes, sir.
Understanding?
Yes, sir.
That is 105%.
Yes, sir.
5% for backwashing. We require QNet as 5% more.
Yes, sir.
That
One
means,
percent.
understood?
Yes, sir.
So tell me the value now.
4331.25.
Or 331.25 meter cube per hour. Clear?
Yes, sir.
Understood how we use this 5% now?
Yes, sir.
Now tell me, rate of filtration is given 6 meter per hour. That is velocity of filtration.
Yes, sir. Rate of filtration.
There is again some. Okay. Now tell me, what that is rate of filtration is nothing but velocity of filtration. How much is it? 6 meter per hour.
Yes, sir.
Now, if you know Q, if you know V, can I get the area?
Yes, sir.
What is area then? Tell me. Q by V.
Yes, sir. Q by V.
Tell me the area.
So 721.875.
721 point
875.
units
Sir, meter square.
meter square. That is the reason we converted it to meter cube per hour, right?
Yes, sir.
So this is total area. See, the filters will be like this. Number of filters. 1, 2, 3, 4, 5, 6, so on. Like this.
Yes, sir.
Now, we know this is one filter bed. One filter bed is, wait, the width of each filter bed is to be kept equal to how much meter?
5.2 meter.
Capital A is total area. I want area of each filter bed. Small a means what it is?
Each filter bed area.
Area of each filter bed. How much is length? Width is 5.2. How much is length then?
Length, sir. Length would be same.
No, no, he given here. If you see, length to
Okay,
width
okay.
ratio is
1.35.
1.35.
One
L
point
by B is 1.35. So how much is L?
1.35 into 5.2.
1.35 into 5.2 will be your length. Into B is 5.2. Can you tell me this area?
.504.
Is it
Yes, sir.
5.2 into 5.2? How much it is?
5.2 square is, sir, 27.04 multiplied by 5.2. Sir, 140, 608.
27.04 into 1.35. 36.504, right?
Yes, sir.
36.504 meter square is the area of each filter bed. Am I right?
Yes, sir.
Okay. Now, how do you get the, what are we asked? Total number of filter beds required are
So sorry, sir. The area is coming 140.608.
How 140.608?
5 point.
5 into 5 is nothing but around 25.
Okay, sir. Okay, okay. It is.
25 into 1.35 will be getting around
Yes, sir. Yes, yes.
36.504,
It
right?
is right. Yes, sir.
Yeah, yeah, great. Next. Now, the number of filter beds is nothing but total area upon area of each filter bed.
Yes, sir.
Clear? Because the total area is nothing but area of each filter bed, small a into number of filters. Yes or
Yes, sir.
no?
Yes, sir.
What is total? This one total area is 721.875 upon 36.504. Can you tell me the answer?
So 19.77 and 20.
Okay. 19.77 means we number of filters should not be in decimal.
Yes, sir.
Always we need to go to next value 20.
Yes, sir.
Now listen. One additional filter is to be provided to take care of breakdown, repair, and maintenance.
Okay, sir. 21.
21. That's it.
Yes, sir.
We require how many filters then?
21 filters.
21. If we gave one for backwash also, then it's 22.
Yes, sir.
Can we move on? Or else will you have a glance at it?
Sir, we can move ahead.
Okay. Let's say this. This we will do. This will consume some time, but we need to do this.
Sir.
Can we do this?
Yes, sir.
Listen. At a small water treatment plant which has how many filters?
4 filters.
Number of filters is 4.
Yes.
Rate of filtration and backwash. Rate of filtration means velocity of filtration. How much it is?
Sir, 200 meters per.
Meter cube per day per meter square. That is 200 meter per day. Yes or
Yes, sir.
no?
Yes, sir.
And velocity of backwash we denote with VB.
1000.
1000 meter cube per day per meter square. That is 1000 meter per day.
Yeah.
Always remember one thing. Backwashing is done at 4 to 6 times the rate of filtration.
Okay, sir.
Clear? Am
Yes,
I
sir.
clear, my dear?
Yes, sir.
4 to 6 times means if I am taking 5, so 5 into 200
Yes, sir.
is 1000.
Yes, sir.
Clear?
Yeah,
So
yes.
what I want to specify, rate of backwash is 4 to 6 times rate of filtration. Always rate of backwash is greater than rate of filtration.
Yes, sir.
And backwashing is done for how much time?
15 minutes per day.
Time of backwash 15 minutes every day,
Yes, sir.
per day. Maturation which occurs initially as filter is put into service after cleaning. That is, time of maturation is how much?
30 minutes.
That is after backwashing. What is maturation? I'm telling you. After backwashing, if the filter need to start cleaning, it requires for purification, for filtration, in order to start filtration, it requires 30 minutes.
Okay, sir.
That means in one day, 15 minutes is for backwash, 30 minutes for maturity. So how much is time of filtration?
23 hours.
23 hours.
15 minutes.
Clear? Any doubt in this?
No, sir.
It is being proposed to recover the water being wasted during backwash and maturation. If we are recovering water during that time also, what is the percentage increase in filtered water? Understanding? Tell me what you understood in this point.
It is the first required to invest. Yes, sir.
What can we infer from this point? Tell me.
Sir,
Mm-hmm.
sir, it is asking increase in filtered water due to the recovery of water which was wasted in backwashing.
Good, 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 good. So first, what we do is water. How much water is used for backwash? Tell me.
Sir, 1,000
Water used for backwash per day, per 1 day. How much it is? Tell me. What is velocity?
velocity 200,
Velocity of backwash.
200 meter per day. Sorry, 1,000 meter per day.
1,000 meter cube per day per 1 meter square.
Yes,
Yes
sir.
or no?
Yes, sir.
1,000 meter cube per day per meter square.
Yes, sir.
Now, for 1 day, it is 1,000 meter cube per day, 1,000 meter cube per 1 meter square of area. Okay.
Yes, sir.
Now, but backwash is done for how much time?
15 minutes.
1 day we have 1,000 meter cube per 1 meter square of area. Yes or no?
Yes, sir.
1 day means, but for 15 minutes, how much it is then? 1 day means how many minutes?
24 into
60.
60.
But 24 into 60, it's 1,000. For 15 minutes, it is X. How much is X then?
Sir, 1,000 by 24 into 60
Into 15.
into 15. 1,000 by 24 into 60. Sir, 10.442.
10.42.
Yes,
416 something.
yes, sir.
10.416 meter cube per 1 meter square area. Yes or no?
Yes, sir.
Now, listen. This is water what we use in backwashing. Okay.
Yes, sir.
Now, let's talk about maturation. Maturation is done for how much time?
Sir, 30 minutes.
Maturation takes 30 minutes. Now, during maturation also, water travels with what velocity? Rate of filtration only. What we need to remember? During maturation also, water travels with what velocity?
Rate of flow.
That means water will travel with rate of filtration, but filtration is not properly done. That is, purification is not properly done during first half an hour after backwash.
Yes, sir.
That means now listen. In 24 hours, that is in 1 day. What is in 1 day? In 1 day, how much water is being maturated, purified? Tell me.
200 meter cube.
200 meter cube per 1 meter square area. So
Yes,
1 day is how much? 24 hours into 60 minutes. Yes or no?
yes, sir.
In this time, 200 meter cube of water will be is purified. Now maturation is for how much time?
15, 30 minutes.
30 minute goes to X. What is this X now? Hmm.
4.166.
Very good. 4.166 meter cube of water per 1 meter square area.
Yes, sir.
Am I right?
Yes, sir.
Now, the thing is, we got how much now, how much maturation and backwash can I consider it as a total water is, tell me, that is combinedly for maturation and backwash. Can I add both the things?
Yes, sir.
10.416 plus.
4.166.
What is the answer then?
Sir, 14.582.
14.58 meter cube of water per 1 meter square of area. Yes or no?
Yes, sir.
We will consider total per 1 meter square area only. Leave about this. Listen now. What is rate of filtration? 200 meter cube per day per meter square of area. Yes or no?
Yes, sir.
Now, that means 200 meter cube of water is filtered per 1 day. Am I
Yes.
right?
Yes, sir.
That means in 24 hours, 200 meter cube of water is filtered.
Yes, sir.
Yes or no?
Yes, sir.
But in 24 hours, 15 minutes goes for backwash, 30 minutes goes for maturation. What is the remaining time, effective time of filtration?
Sir, 15, 30, 30, 45. 23 hours and 15 minutes.
23 hours, 15 minutes, right? So
Yes, sir.
now, 24 hours, how much is the water filtered? 200 meter cube. Yes or no?
Yes, sir.
In 24 hours, the water filtered is 200 meter cube.
Yes.
24 hours is how many minutes?
24
24 into
into
60
60.
goes to 200 meter cube. But effective time is how much?
23 hours, 15 minutes.
So, in 23 hours, 15 minutes means 23 into 60 plus 15. Yes or no?
Yes,
This
sir.
is in minutes plus
Yes, sir.
15
Yes,
minutes.
sir. Yes.
How much is the water actually filtered in 24 hours time after wastage? See, the motto is not to make you easy. Because when you have such questions, also you need to be in a position to answer. Yes or
Yes,
no?
sir. Yes, sir.
Please tell me the value.
Yes, sir. I'm doing, sir.
What is 23 into 60 plus 15?
Sir, 1395.
1395. And this one is 1440. Am I right?
Yes, sir.
So x is equal to 200 into 1395 upon 1440. What is the answer, Noma?
No, 193.75.
1.
93.75.
Wait, my dear. Wait. There is some error here. Why I'll tell you. Why I'll tell you. Okay. Let's stick back up to this point. Okay, clear? Let's stick back up to this point. 23 hours 15 minutes is net effective time of filtration. Am I right?
Yes, sir.
In 1 day, 200 meter cube of water should be filtered. or no? Out of the complete 200 meter cube of water, in one day, in backwash, how much is the water lost? Tell me. We already calculated.
10.416.
So let's remove it. 10.416. Next, in maturation, how much is the water lost?
4.166 meter cube per meter square area. 4.166.
That is, in one day, 200 meter cube of water is filtered. I'm talking about in one day only, 200 meter cube of water is filtered. Out of that filtered water, because the for backwashing, are we using raw water or filtered water?
Filtered water.
If we are using raw water, means the filter condition will be damaged.
Yes, sir.
So 10.416 meter cube water is for backwashing. Where this water comes from? From the filtered water only.
Yes, sir.
Minus how much is the water that is wasted during maturation?
Yes, sir. Minus maturation 4.166 meter cube per meter square area.
4.166 meter cube. This is all per unit area only.
Yes, sir.
Okay. Now tell me how much is the net you have? That means you have 200 liter of water. You are losing 10 liter for backwash, 4 liter initially as a wastage. So 200 minus 10 minus 4. How much is it?
185.418.
185.418. Let's make it 185.42 meter cube of water.
Yes.
Now, what is our question? Percentage increase in filtered water. That is, if it is proposed to recover water being wasted during backwash and maturation. What is percentage increase of filtered water? That means, listen. Percentage increase means how much is total water wasted for backwash and maturation utilized? How much it is?
14 point
14 point. We calculated 14.58.
yes, sir. 14.58 meter cube.
14.58 upon what is actual water filtered?
200 meter cube.
But out of that, we are losing it, right?
Yes,
Wait,
yes.
okay. Total filtered is 200 into 100. How much is the answer? No, no, don't take this. Take always this net filtered only. 185.42 into 100.
7.86.
Percentage. That's it.
Yes, sir.
Can I explain once again?
Yes, sir.
Listen. We have calculated how much water is utilized for backwashing. First step.
Yes, sir.
Next step, we have calculated how much water is utilized in maturation.
Yes, sir.
Next, the total water, we are adding both the things.
Yes, sir.
Is there any problem in these three steps?
No, sir.
Next, we will go on. Total in 24 hours, 200 meter cube. But in effective time, we have this one. Because why I am not doing this is, this will be right only if backwashing and filtration are done at the same rate.
Yes, sir.
But in backwashing is done at higher rate. So backwashing we are having higher volume of water.
Yes, sir.
Maturation, this is the volume. So out of total volume, Remove backwashing, remove maturation. What is the remaining water left for you?
185.42.
185.42. Now you are planning to increase, restore this also. So how much is the increase, percentage increase? If we ask directly that what is increase in water? 14.58 directly. But what is asking you?
Percentage increase.
Percentage increase. So 14.58 divided by how much is the water you are filtering? Net filtered water is 185.42 into 100.
Yes, sir.
Understood?
Yes, sir.
See, this is the toughest question you can expect from filtration.
Okay, sir.
Toughest question, I can say.
Okay, sir.
Remaining questions will be as easy as it is.
Okay, sir.
Yeah, let's do this. We can move to the next question, right?
Yes, sir.
There is a formula here. I'll explain this to you. A 0.8 meter deep filter bed of sand filter. The depth is how much?
0.8.
Depth is 0.8 meter. Length and width are given. Is made of uniform particles. Diameter 0.4 mm. Specific gravity 2.65. Shape factor 0.45. With bed porosity. Porosity is denoted by N. We seen in geotechnical engineering.
Yes, sir.
The bed has to be backwashed at a flow rate of how much?
3.6.
3.6 meter cube per minute. Backwashing is done means in this direction. From the bottom to the top. Yes or no?
Yes, sir.
Due to heavy backwash, will the bed get expanded? See, the bottom we have some support. But do you have any support for the filter bed at the top? No support.
No, sir.
So due to backwash, can I say the filter bed gets expanded?
Yes, sir.
This is depth Z and this is ZE, expanded Z. Okay.
Yes, sir.
Now, the bed has to be backwashed. During backwashing, terminal settling velocity of sand particles. During backwashing, sand particles are going to settle at this velocity. Expanded bed depth is how much? So he is asking you how much is ZE.
Yes, sir.
Okay. Now I'll tell you one thing. ZE by Z, we have a formula equal to 1 minus n upon 1 minus NE. What it is, ma?
1 minus n over 1 minus n.
ZE by Z is equal to 1 minus n by
1 minus
1
n.
minus NE. Because we take like this. ZE into 1 minus NE equal to Z into 1 minus N, where N is the porosity initially. NE means porosity of expanded sand bed.
Yes,
What
sir.
is NE?
Porosity of expanded sandbag.
Because after expansion, the porosity remains changed.
Yes, sir.
Now, you know this N, yes or no?
Yes.
0.4. You know Z. How much is Z? Depth
0.8.
0.8. Now, if you know NE, you can get ZE. Yes or no?
Yes, sir.
Now, how to get NE? NE equal to VB into n to the power of 4.54554. Okay.
Yes, sir.
VB n equal to VB into n to the power of 4.54. This is the formula again.
Okay, sir.
Yesterday I told you directly the formula oriented questions will be there.
Yes, sir.
Okay. Now tell
Yes.
me what is VB, velocity of backwash. How much is it?
Sir, 3.60
Meter
meter.
cube per minute. Let's convert to SI units. 3.6 meter cube per 1 minute is how much, ma?
60 seconds.
Seconds.
Yes, sir.
How much it is then?
0.06 meter cube per second.
0.06 meter cube per.
Second.
But meter cube per second means discharge, right?
Charge. Yes, sir.
But what we want is velocity. Therefore, divide with area.
Yes, sir.
What is area? L into B.
L into B
4
4.
into 3. Tell me the answer now.
Sir, 5 into 10 power minus 3.
5 into 10 power minus 3 units meter per second.
Yes, sir.
So 5 into 10 power minus 3 into n is how much? 0.4 to the
0.4.
power 4.54. Answer. Hmm. Wait. Sorry. Sorry. Have you calculated this one? VB 5 into 10 power minus 3 meter per second, right?
Yes, sir.
Now the formula remains like this. VB equal to Vs into Ne to the power of 4.5. VB equal to Vs into Ne to the power of 4.5.
Okay, sir.
From this, what is Ne? VB we know.
Yes, sir.
5 into 10 power minus 3 equal to Vs is how much? Settling velocity.
Sir.
Terminal settling velocity of sand particle. How much is Vs?
0.05. 0.05.
0.05 into Ne to the power 4.5. Tell me Ne now. As simple as it is. How much is the answer?
Sir, 0.1.
No. Wait. Then what about this 4.5?
0.5. And
See, NE to the power 4.5 is 0.1. Okay. NE equal to 0.1 to the power 1 by 4.5. Tell me the value now.
sir, 0.599.
Can I make it to 0.6?
Yes, sir.
0.6. Any doubt in this, ma?
No, sir.
Simple. We converted VB to meter per second. We used this formula VB equal to VS into NE power 4.5. We know VB, we know VS, and why I converted to meter per second means in order to bring VB to the unit of VS, meter per second. Okay,
Yes, sir.
and we used this formula. From this we got NE simply. Now let's substitute in this equation and get ZE. ZE by, that is how much? 0.8 equal to 1 minus n is 0.4 upon 1 minus ne is 0.6. What is ZD then? 1 minus 0.4 is 0.6. 1 minus 0.6 is 0.4 into 0.8. Answer.
1.2.
1.2. Expanded sand bed. That is how much is this portion? Can you tell me? Total after expansion, expanded sand bed ZD is 1.2. For suppose if the in the question if we ask you how much is depth of expansion, expanded sand bed depth means total depth. Our
Yes, sir.
answer is right. Expanded bed depth means total depth. But how
Yes.
much is expansion done?
0.4.
Very good, very good. Any doubt in this question?
No, sir.
Is it easy?
Yes, sir.
If you know the formula, it's easy. Okay.
Yes, sir.
Shall we solve one more problem?
Yes, sir.
Not exhausted?
No, sir.
Very good, very good. We'll do this tomorrow. You just remind me.
Yes, sir.
This chlorine gas problem, it will take some time. I will explain this to you in detail.
Okay, sir.
Okay?
From which topic this question is?
Disinfection.
Disinfection. Okay, sir.
But this is very important problem
Okay, sir.
because if such models comes, how you need to how you solve is important. See, the thing is not covering more concepts. The thing is how important is the class to you.
Yes, sir.
We'll do this. A wastewater is to be disinfected. Disinfection is mainly done by chlorination. Okay?
Yes, sir.
A wastewater is to be disinfected with 35 mg per liter of chlorine to obtain how much kill?
99%.
99% kill. Number of microorganisms remaining at any time t is given by nt equal to n naught into e power minus kt. Listen, ma. Always this point may be given, may not be given. You don't expect this point.
Okay, sir.
Always disinfection means it obeys Chick's law. Which law? Chick's law. What does Chick's law states? Nt equal to n naught into e power minus kt, where n naught is initial number of microorganisms, nt is number of microorganisms present at given time t.
Yes, sir.
Okay. That is, before treatment, initially at time t equal to 0, number of microorganisms present is n naught. After some time of disinfection, number of microorganisms increases or decreases?
Decreases.
Decreases. So how much are they? Can be calculated by Chick's law of disinfection.
Yes, sir.
Okay, first law of this one, exponential reaction like this. This is n naught at some given time t. This is nt. Microorganisms decreases exponentially. That is the reason we took E. Okay.
Okay, sir.
The wastewater flow rate is 36 meter cube per hour. Q we have. Flow rate means Q, discharge. Meter cube per hour. K is 0.23 per minute. Okay. Depth and width of the chlorination tank are given. What is the length? Okay.
Okay, sir.
Now, if you know volume, can I write volume is L into B into H?
Yes, sir.
In this, you know length, you know width. Sorry, you know width, you know height. Depth is known, H. Width is known, B. I want L. That means if can I get L by finding volume?
Yes, sir.
Great. Now, volume is equal to discharge into detention time. Volume units is meter cube. Detention discharge unit is meter cube per second. Detention time is seconds. This is what you need to remember.
Yes, sir.
Either for filtration or sedimentation for any treatment in environmental engineering.
Yes, sir.
You need to remember which formula. Volume is equal to discharge into
Detention time.
detention time. Now, now you know discharge already. Yes or no?
Yes, sir.
36 meter cube per hour. I want the detention time. Detention time here means nothing but time of disinfection.
Yes, sir.
Yes or no?
Yes, sir.
So that means nothing but this equation only. Okay. Now, what is percentage kill of microorganisms? Tell me.
99%.
99%. I will tell you one thing. Percentage kill means n naught minus nt by nt. Yes or no?
Yes, sir.
Or else can I tell you in other word?
Yes.
99% killed. How much percent is remaining?
1% remaining.
How much?
1% remaining.
1% remaining. Yes or no?
Yes, sir.
That is nt is equal to 0.01 n naught. Yes or no?
Yes, sir.
N naught into 1%. N naught into 1 by 100.
Yes, sir.
Yes or no?
Yes, sir.
Nt is equal to n naught into 1 by 100.
Yes, sir.
That is 0.01 n naught. Can I
Yes.
use this here directly in the
Yes.
Chick's law equation?
Yes, sir.
0.01 n naught equal to n naught into e power minus kt. N naught and n naught get cancelled. 0.01 equal to e power minus k is 0.23 units 1 by minute. Then t will be in minutes.
Yes, sir.
Yes or no?
Yes, sir.
Tell me t. Do you have any doubt how to solve this? Can I tell you?
Yes, sir.
Take this e to this side. Minus 0.23 into t is equal to log of 0.01 to the base e.
Okay, sir.
Now tell me the value. Log of log base e. Natural logarithm of 0.01. How much is it?
Log point.
Minus 4.6.
Yes, sir. Minus 4.6.
Now minus and minus gets cancelled. T
Yes.
is equal to how much? 4.6 by 2.3, 0.23.
Yes, sir.
How much is it, ma?
Sir, 20.02. 022.
Okay, that means 20 units, minutes.
Yes, sir.
Yes or no?
Yes, sir.
Now, you know V equal to Q into dt. V
Yes, sir.
equal to Q is how much?
Q is
36 meter cube per hour. Hour, let's convert to minutes since time is in minutes.
Yes, sir.
1 hour is 60 minutes.
Yes, sir.
Into time is 20 minutes.
Yes, sir.
Answer.
12,
20 is
12,
3
sir.
times 60,
12. 12.
12 meter cube. But now 12 is nothing but L into B into H.
Yes,
L
sir.
into B is 1 meter, H is 1.5 meter. What is L now?
Sir, 8, sir.
8 meter. I'm telling you, these model of questions are very, very, very important.
Yes, sir.
Okay.
Yes, sir.
If you understand this concept, you can do such model of questions.
Yes, sir.
Shall we
I-
wind up now?
yes, sir. Yes, sir.
It's already the time. We will meet up again tomorrow at 7 o'clock.
Yes, sir.
Okay.
Okay, sir.
Don't miss the session. Tomorrow also we are going to discuss very, very important things.
Yes, sir. Sir, along with practicing these topics, what do I need to practice for tomorrow's topics? Tomorrow's question.
Tomorrow, let's do one thing. Yeah. You practice characteristics of sewage.
Okay, sir.
That means BOD problems,
Okay, sir.
BOD problems, BOD COD problem, BOD equation and problems. And next, you just practice BOD problems
Yes, sir.
and practice these things.
Yes, sir.
Also practice quality of water. That is problems on hardness, problems on alkalinity, problems on hardness and alkalinity. They are very common.
Okay, sir.
Okay. Actually, environmental is very vast.
Yes, sir.
But I'm telling you, the problems what I discussed today is very beneficial. It will be very, very beneficial for you.
Okay, sir.
For GATE, for any competitive exam, it might be, it will be very beneficial.
Okay, sir.
Okay.
Yes, sir.
Hope the sessions are useful for you.
Yes, sir.
Understandable.
Yes, sir. It is
Okay.
understandable.
Let's do it tomorrow.
Yes, sir.
Let's meet up again at the same time tomorrow, 7 o'clock, with same subject.
Okay, sir.
Okay.
Okay, sir. Good night.